Okay, so just a moment. So I'm assuming that everyone must have cleared calculus 1, right? Or you still need to pass it. Is there anyone without calculus 1?
I have just some small problem with the integral.
Okay. But do you have the basically over the idea, like let's say the limit, the Fermat's theorem, the Wester's theorem? Do you have all clear idea? Like you don't need to like do you know all the stuffs that we use in calculus 1?
Uh, Somehow, yes, maybe. I don't know about the others.
Okay, I don't ask. So I don't expect you that you should able to solve computationally. I don't want it, but you just need to have the basic conceptual knowledge from calculus 1. You're gonna see it like, see, this course is a crash course. Like it's gonna be a little bit more than crash course. I will only focus on the exam oriented question, like what the questions you're gonna see here. It, and the exam questions will be completely similar. For the first call, it might be the same. I don't know, because the first call, in every exam, the first calls are quite general, and we can predict almost, let's say, 60% or 70% of the questions in the first call. So, yeah, so let me just share you the generic strategy which I gonna do for calculus 2. So, you have 5 questions. Yeah, out of which 4 will be exercises. Like you need to solve them. It will be like some direct exercises that you will see here, and there will be one question. And this question, the- like it is usually a bit difficult because it is not a direct question. It will be an application based question on the theorem which is available in the material. It is not, so it's not a direct theorem question or not a proof, but it's an conceptual question. uh, as per my analysis, which I have seen since last 3 4 years, this question in the first call is kind of always easier than the other um, calls. So, so this is just my point of view. I don't know about a generic idea. So, in first call, I have always seen this question to be easy. So that's why I say, like in the first call, the exam will be kind of easier than the other calls. So you're gonna see how we're gonna do it. For the exercises, there is a bit change, as I have noticed from the materials, uh, compared to last year's, and the change is in differential equation. Since this topic was covered in calculus 1, so here you're gonna see the advanced topic of differential equation. So um, you shouldn't refer the past year exercises for this chapter basically, and then for rest of the chapters, it's fine. We can refer to previous year questions, but for this chapter we need to study it from the beginning, like the change. And yeah, so let's start with today's topic. Do you have any question which we can address before, like any doubt regarding the course, how it gonna be, how many classes? Okay, yeah, most important thing, there gonna be 10 classes for calculus 2, and I'm keeping one class reserved, so 11 classes. And you're gonna have two simulations, one in, let's say, after 5 classes, which gonna cover like 2 or 3 topics, and The other simulation will be the whole course, and it's gonna be like similar to your exam question paper. Apart from this, if you have any question, you can ask me now, or else we will proceed with the today's topic. Okay, no questions. Okay, let's directly jump to the questions. Maybe you might have seen this kind of questions in calculus 1 as well. Let me just remind you. Okay, so the first topic of our course is Fermat's theorem. It's from calculus 1. So you have already seen this theorem. Is there anyone who gonna say what is Fermat's theorem from calculus 1? You can try it. Don't worry about it if it is correct or wrong. It's fine. Okay. So if there is a function, and let's say the function is uh, on the vector of x, and it's going from D to R, okay, and f is also differentiable on D, and x belongs to the interior of D. I will show you in a question. You don't need to worry about these terms, but I'm just defining the theorems because you might need it in the theory exam. Don't worry, I will explain it in the simple terms. Let me just state it first. Okay, so basically the Fermat's theorem says that if you have a function on vector of x or maybe x, and it goes on the from domain to D to R, and f is differentiable on the domain side. Yeah, and f is differentiable on D, and x is belongs to the interior of the T. So x is inside the domain, and if it is a local minima or local maxima, then it must be a stationary point. So just to summarize this part, I can say if x belongs to interior of D and it's a local minima or local maxima, then it must be a stationary point. But the reverse is not true. Let's see with a question. It will be more clear to you. So we have a function, and it's the function of x and function of y, and the function is x square plus y square, and let's say the domain D is x square plus y square less than 1. So my first question to you is draw D. You will always have this question in the exam: draw D, or prove that D is not a null set or something. So let's try to draw D, and you can see here, and this is the function of x square and y square less than equal to 1. And from this equation you can get it. Let's say this one, if this is my x, this is my y, and the maximum value 1, So it's gonna be a circle of radius 1. Okay, I can modify the points. So this is my D. The work is not completed here because x plus y square is less than equal to 1. So this whole red shaded area is D. And yeah, so we have to find the local minima and local maxima, or maybe the stationary point here. Just this question is to, like, okay, why I'm solving this question, just to prove this point, and then I will show you, then I will explain you the theorem, how we're gonna use it in the question. Okay, let's find out the stationary point. Okay, so let me state one theorem for you. So to find the stationary points, you just need to do the gradient of f equal to 0. So here we have f of x y is x square plus y square, and to find this gradient of f x y equal to 0, so this is nothing but this is the partial derivative of this whole function. If I'm just writing f, you assume that this is a function of x and y. So this is the partial derivative of f with of f with respect to x, and the partial derivative of f with respect to y. And this must be equal to 0. And if we equate to 0, we will get the stationary points from here. So to find the stationary point, you need to do the gradient equal to 0, and you will get your stationary point. So let's find the partial derivative of f with respect to x. So when you find the partial derivative of f with respect to x, uh, this is gonna be 2x plus 0, because we are finding the derivative with respect to x, and this function is y. So this, it will assume that this is a constant from calculus 1. And similarly, if you find the partial derivative of f with respect to y, it will assume the first one as constant, so 0 plus 2y. I got my gradient of f as 2x 2y, and then I have to equate to 0. Uh, Actually 0 vector, because here you have uh, two functions here. So it's gonna be wrong if you write just 0. Rather, you can write 0 vector or equate to 0 comma 0. You can prefer any of this. So from here I got x equals to 0 and y equals to 0. So what is this? This is my stationary point. Then I have to check, uh, is it a, okay, is this point inside D? Can you check? Is this point inside D? So what was my D? This was my D, and x 0 comma 0 is here. Sorry. So clearly it is inside D, and we have to check whether it is a minimum point or a maximum point. Let's um, so this was our function. Let me just rewrite the function. Function was f of xy x square plus y square, and you see this, both of them, they are square functions, so this cannot be negative. So x square will be always greater than equal to 0, and this one will be also always equal greater than equal to 0. So the lowest possible point, it gonna be greater than equal to 0. So the minimum point is 0, and if you put x equals to 0, so if you substitute this point 0 comma 0, so it's 0 square plus 0 equals to 0. So this is a minimum point. So what I did here basically, uh, I found stationary points, and then point or points is fine. Then I check minimum or maximum point. So I got that the point which I found, it is a minimum point. So this was kind of our first remark. And do you have any question here, like in the computation or maybe in a conceptual? No questions? Do you want me to recap this one? Okay. So we are given with a function f, and then we have the domain d. So the first question I asked to draw the d. So d is the domain, and this was a circle equation, but a bit different. The equation of circle is like x square plus y square equal to 1. And since this was less than equals to 1, so I said it all the area inside the circle. If this would have been written x square plus y square greater than equal to 1, so I must have stated all the area that is outside the circle, like outside our domain. And yeah, then I tried to find out the stationary point, and there is a strategy to find the stationary point. You need to like equate the gradient of f equal to 0. So this is a method for finding the stationary point. And then we have our f of xy, the function of x and y was x square plus y square. And how to find the gradient? This was the formula to find the gradient. You need to find the partial derivative of the function with respect to x, and then the partial derivative of the function with respect to y. Imagine if the function would have been like x, y, z. So to find the gradient, you need to do, so you need to also find for z as well. And then you need to equate to 0. Why? To find the stationary point. Uh, so I got my like the partial derivatives as 2x and 2y, and then I equate them to 0 to get the stationary point. And when I equate to 0, I got x equal to 0 and y equal to 0. So this was my stationary point. And then I checked whether this stationary point is inside D or not. So I got to know this is the center of the circle. So it's 0, comma 0. And then uh, I analyze the function, the maximum value and the minimum value. And if you see the minimum value, it was kind of easier to see the minimum value because this is a squared function, and the lowest possible value will be like, for this one is 0 and for this one is 0. So the function must be greater than equal to 0. And then when I substitute this stationary value, the stationary point inside my function, I got the minimum value, that was 0. And then so I said the stationary point which I have found here, it is the minimum point. So this was the overall idea for the first question. Oh, I found one stationary point or points, then I check for whether the point is a minimum point or a maximum point. In this case, I got this is the minimum point. Okay, so let's then move to the second remark. Okay, remark 2. Here you have a function x comma y, and this is x square minus y square. And I would like to keep the domain as same here. X, y, this is x square plus y square less than equals to 1. So always you have to draw D. So draw D. It is the same one as above. No changes here. Okay. And then mm, just a minute. So you have your function as x, y square minus y square. And then let's find the gradient of f of xy. So you need to find the partial derivative of f with respect to x. Then you have to find the partial derivative of f with respect to y. So when you're finding partial derivative of f with respect to x, it's gonna be like 2x minus 0. And here it's gonna be 0 minus 2x, 2y. So I got 2x 2y. And then to find the stationary point, you need to do the gradient of f equal to 0. That means 2x must be equal to 0 and minus 2y equal to 0. I got the same point as well. Here x equal to 0 and y equal to 0. So the stationary point which I got is 0 comma 0. Then I have to check whether it is a minimum point or a maximum point. So let's just analyze the function a bit. Okay, so if you observe this function, let's what happens if x is equals to 0 and y is any value. So this is gonna be minus y square, right? And also let's do the same. What happens if y is equal to 0 and x is free? So this is gonna be x square. And let's also try to substitute this stationary point which we have got here. So when I substitute this 0 comma 0, you will get 0 square minus 0, that is 0. Please note here, this is not a mean point or not a maximum point. This is neither a minimum point nor a maximum point. You can clearly observe this is a minimum point and this is a maximum point. Like 0 comma y is gonna be the minimum point. I don't know what is exactly 0 comma, like what is the exact value of y. We are just keeping it away from now. Now I just want to prove that the stationary point which we got here is not a minimum, neither a minimum point nor a maximum point. But in the above question, if you see the stationary point which I had got here, it was a minimum point. So if we go back to our theorem state that if you have a function and the function is on x vector and it's go from domain to R and f is differentiable on D. So what I got, if a point is a local minima or a local maxima, then it is a stationary point. So let me just write this one. So if it is local minima or local max, then it is a stationary point, then it is also a stationary point. But the reverse case is not true. Why? Because I solved in the second remark. If you see here, I got a stationary point, and then when I substitute here to find the minimum point or maximum point, I got it's neither minimum nor maximum. So if you have a stationary point, you cannot directly state that this point gonna be a minimum point or a maximum point. But if you have a minimum points and maximum points, you can clearly state that these minimum and maximum points are one of or maybe two of among many stationary points. Is it clear? So you can use the text, or maybe you can just unmute yourself like for 1 minute or maybe for a few seconds. Then you can say, okay, it's clear, then I can move. Okay, so let's move to bit exam type of question. So we are moving, step by step. And then in the next class, you will see a similar question from the past year paper. I'm gonna pick it and then we will solve together. So just a moment. Okay, so exercise one, you have a function x, y, and x plus y minus xy. This is a function, and you have the domain D as x greater than equal to 0. And okay, let me just write the question first, then we can discuss. Okay, so this is a question where you have a function and you have the domain. In the first bit, I'm asking you to draw the domain. In the second bit, I'm asking you to state whether the D is compact or not. I will say you what is compact. And then I'm asking you whether the function is differentiable on D or not. And then stationary point and minimum maximum point. So if you observe this question, you're gonna find out in exam you kind of have the same questions, but a bit difficult exercises, and not this much easy. Uh, I picked this one because I want to focus on concept right now by solving exercise rather than just see this is a crash course. I will not cover all the theory, you know the theory first and then going to the exercises. No, I will simultaneously solve the exam type of exercises, and then in those exercises I will state the theory behind it. uh, for these exercises this trick gonna be work, but for the topics which are completely new for you, we need to cover bit theory and then we have to go for exercises. But these exercises are kind of bit general and is similar to calculus 1, but this is the extended version, this exercise. So we will move from very simple exercises, not very simple, simple exercises to intermediate, and if possible to the difficult exercises, which gonna be like the worst case scenario in the exam exercises. But for sure, in the first call, as we have, as I have observed, like those questions are kind of bit general. Professor doesn't usually ask, those difficult exercises in the first call. So anyone have idea like how we can solve this one? So how to draw D solution? Can anyone suggest me how to draw D? It's very simple. Just try. Don't worry if it is correct or wrong. Come on. You have two constants here. One, x is greater than 0, and the other is y's boundaries, like it lies between 0 to 3 minus x. So it was my x. No, it's a y. This is x, and x is greater than 0. So a minute, that means this area completely. And y lies between 0 to 3 minus x. And okay, can anyone say me what is this? Like, this is the equation of which geometrical figure? Anyone? I repeat, this equation is similar to which geometrical figure? Like, this is the equation of which geometrical figure? Whether it is a circle, sphere, line, parabola.
The parallel line, it's a line,
See,
actually.
okay, it's a line. Uh, the term which you said, parallel,
Parallel,
you need to consider two lines and you have to compare. That's a comparison term.
parallel
Okay.
to Y, maybe.
No, 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 no. This my question was, this is the equation of which geometrical figure? The answer is simple line. We don't know about is parallel, perpendicular. See, for this parallel, perpendicular, we need one more line to compare with it. So those are just comparison term. One is better than other one. So the better term needs two quantities. So here we don't have two things. I just asked if this is the equation of what thing. So this is the equation of line,
Hmm.
and how to draw a equation of line. Can anyone? So do you guys know about y-intercept, x-intercept terms, which is kind of pre-calculus maybe? Okay, don't worry. So let's try to draw this one. Let's put x equal to 0. So when you put x equals to 0, your y equals to 3. And when you put y equals to 0, x will be 3. So you got two coordinates, 0 comma 3 and 3 comma 0. So this is these are the two coordinates here. And try to um, form a line by joining these two coordinates. So this is my y equals to 3 minus x. And what is y equal to 0? So this line is y equal to 0. No, no, sorry. This line is y equal to 0. So if you see this one, what it is asking you, the y should be greater than like this equation. So like you, it must be in this direction, all these points, and your y must be less than 3 minus x. So it must be in this direction. So let me just use different color for this one. Can anyone say me what is the common area for blue, red, and black? So what was blue? Blue was x greater than equal to 0. That means all these areas x greater than equal to 0. So this is the common area between all the three. Do you agree? Do you have any doubt in this part? How I draw D? So this is my D. Any questions here?
No.
Okay. So yeah, this was my first bit, and the second bit is D compact. Can anyone answer me what is the meaning of compact? If you have attended, let's say, one or two lecture, you might have heard this term from professor several times. Uh, is the compact. So for compact, you need to check two things. What are those two things? Okay. So the first thing, D must be, so you have to check is D closed. The second thing is D bounded. So what is the meaning of closed? So how to check whether D is closed or not? See, if you go to the theory of the first chapter, you will actually get it like what is the meaning of close, what is the meaning of open. I'm not gonna cover those things here. I will directly say, okay, how to solve this kind of questions in the exam, and which is the most common thing which you will do. Uh, so to just to check whether D is closed or not, you have to here if you see, just a minute. Yeah. So if you see here, D is made up of uh, continuous function. Like here, one function is x is greater than 0, and the other function is the y is lying between 0 to 3 minus x. So whatever you see here is all continuous, since D is all continuous function or inequalities. So D is closed. And for the second thing is D bounded. Actually, for this one, you have to show it. Like you have to show the boundaries of uh, x and y of all the parameters. So to show this one, you have to prove, is there any upper bound and lower bound exist for both the quantity or not. So if you observe this function, this part, and also this function as well. So here x says that x is greater than 0. So we have a lower boundary for x, that is 0. We don't know about the upper boundary. And for y, it says that for y, you have the lower boundary as 0 and the upper boundary as 3 minus x. And if you clearly observe this figure completely, you will find out the maximum value of x, it could be 3, right? So I can state the maximum value of this of x, it could be 3, and the lowest value of x is gonna be 0. So if you put here x equals to 0, let's say 0 comma 3 minus 0. So here you got the boundaries, the upper and lower boundaries for x and y. So you can say here, since x lies between 0 to 3 and y also lies between 0 to 3, D is bounded. Since D is closed and bounded, that means D is compact. Is it clear here? Like what I did? You wanna see this question for sure, like to check whether D is compact or not. Even if it doesn't ask, like these questions can be asked in the other way. I will show you, but what will be the text of the question. But the overall idea, the overall procedure, you need to go this way. So let me just say you one more thing. I think your professor name is Paulo Guito, and he was the same professor that I gave the exam. His marking is very good, but you need to write everything carefully. Like whatever you are assuming, whatever you are thinking, you have to write in the paper. You so you just need to state, okay, you cannot say okay D is closed. No, you have to say since D is constitute of all the continuous function and inequalities, then D is closed. And for a boundaries, is D bounded? So if you directly write okay, no, D is closed and D is bounded and D is compact, so you will not get any point for sure. At least you have to state it. Whatever you are writing in the paper, you need to state them, you need to prove them. So for bounded, you need to show the lower boundaries and upper boundaries of all the variables that is present. Since here there was x and y, and I found out the lower boundary of x is 0 and the upper boundary of x is 3, the lower boundary of y is 0 and the lower upper boundary of y is 3, then I got okay, my D is bounded because of this thing. And since D is closed and bounded, so D is compact. Is it clear? Any questions? Okay. So let me just move to the next part. Okay. The next question I am asking you is f is differentiable on D or not. So let's solve C and D together. Why? Let me say you. So for part D, I'm asking to find out the stationary points of f on D. So you know the trick how to find the stationary point. This gradient of f must be equal. If you equate to 0, you will get the stationary point. Let's find out this gradient of f. And this is the partial derivative of function f with respect to x and the partial derivative of function f with respect to y. And then you need to equate to 0. I will do it later. But what is the partial derivative of f with respect to x? So what was my function? My function here is x plus y minus xy. So let me just rewrite this one. X plus y minus xy. So if you find the partial derivative with respect to x, this is gonna be 1. So Just write partial derivative f with respect to x. It's gonna be 1 plus y, and then this one, yeah, sorry, 1. This gonna be a constant for here for x, and here you will get y. Similarly, if you find the partial derivative of f with respect to y, the first term will be treated as constant, so it's gonna be 0, and the second term is dy by dy, and it's gonna be 1, and the third term is xy. So you have this thing, just a minute, with respect to, so this is basically xy with respect to y, and since you are finding the derivative with respect to y, that means x is a constant, so you can take out this x here. So it's 0 plus 1 minus, so I take out this x, and dy by dy is equals to 1. So I got 1 minus. Here I got 1 minus y, and here I got 1 minus x. Did you got the point? So while finding the partial derivative, the function with respect to which I am finding, which I am finding the partial derivative, I will consider them, and the rest I will consider them as constants. Is it clear? Okay, so I found my gradient of f as 1 minus y, 1 minus x. Okay, before finding the stationary point, let us check whether this is, since our question was to check also for is f is differentiable on d or not. So to check whether this function is differentiable on d or not, you just need to do one thing. Uh, Here, whatever term you have found out, so you got your d, your partial derivative of f with respect to x, and you got your partial derivative of f with respect to y. You have to check whether they are continuous on d or not. So what is this means? You have to check whether, so if you see what I got, this one is 1 minus y and this is 1 minus x. I can clearly say that this is an equation. So this and this are a continuous function on d, because it is an algebraic function, it's a polynomial function. So all the polynomial function, exponential function, they're all continuous. So since it is continuous, that means f is differentiable on d. So this is the way you have to show. You have to find out the gradient, and then you have to show the partial derivative of function with respect to the variables, whether it could be x, y, z. You have to show if all of them they're continuous, that means your whole function gonna be differentiable on d. Okay, and then the next bit was to find out the stationary point. So how we can find out the stationary point? We just need to equate the gradient of f equal to 0. So 1 minus y equal to 0. I got y equals to 1, and 1 minus x equal to 0. I got x equals to 1. So what is my stationary point? Is 1 comma 1. Is it clear until here? Any doubts? Any questions until here? No? Okay. Okay. Since this is a very important part, so I'm giving more emphasis. If you have any questions here, please just ask me now, because when we will move to more difficult questions, it's gonna be, you know, okay, can you repeat? For sure. Do you want me to repeat the whole part, or like, is this one clear? Okay. So the first part was to draw D in this question. So you have the function of D here, and our D is made up of two things. One is this part, and the second part is this one. So I just draw this two part independently, and then I combine them. So let me just recap here. If you see x equals to 0, this is my x and this is my y. So x is greater than or equal to 0, that means this whole part. And then you have the second condition as y, the boundary of y, 3 minus x. So let's observe this part. This is y, this is x, and y is greater than or equal to 0, that means this whole part. And let's check about this condition. So this is an equation of line. I found out the coordinates here. So, and y must be less than this line. So it's this part. So if you combine these three things, this one, this one, this one, you get this. So this is my D. This is the first question. And the second question, whether D compact. So if it is asking you whether D compact, that means it is asking for two things, whether D is closed and D is bounded. So if you prove this is closed and this is bounded, and then we can say, okay, no, D is compact. So you need to prove these two things. So how to prove D is closed or not? So for closed, you just need to check whether D is made up of continuous function or not, or inequalities. So since here D is made up of all continuous function and inequalities, see, these are all continuous and inequalities, so I can say D is closed. But for D is bounded, you have to state it. Actually, you cannot, there is no direct way to show D is bounded or not. So for this thing, what you have to do, you have to, so you have to find the upper bound, the lower and upper bounds of the all the variables that is present in D. So here we have two variables, that is x and y. You have to find the lower boundary of x and upper lower boundary of x and y, and the upper boundary of x and y. So from D directly I get the lower, since it was given in D that x is greater than or equal to 0. That means the lower boundary of x is 0, upper boundary I don't know yet. And for y also the same. I know the lower boundary is 0 and the upper boundary is 3 minus x, and the upper boundary depends on y. So depends on x. And if you see this figure, you can get the maximum value of x is gonna be 3. So I got the upper boundary and lower boundary for x, and let's check whether we have a upper boundary or lower boundary of y or not. So the lower boundary of y is 0, and the upper boundary, if I put x equals to 0, I get the upper boundary of y. So here my x is also bounded, y is bounded. Since both the variables are bounded, that means this is a compact function. So this, the D is compact. So since this is D is closed and D is bounded, then I can say D is compact. And for the third part, I'm asking whether D is, whether your function is differentiable on the domain or not. And the next part was to find the stationary point of the function on D. So do so for to check whether the function is differentiable on D, you have multiple ways, but I will suggest you the most fastest way and most easier way is to find the gradient. So first step, you have to find the gradient of f. So how to find the gradient of f? It is the partial derivative of f with respect to x and the partial derivative of f with respect to y. When you found the partial derivative of f with respect to x and with respect to y, you got 1 minus y and 1 minus x. And then you have to check whether these two are continuous on D or not. Since this is a polynomial function, an algebraic polynomial function, you can state that this is a continuous function on D. So it is clearly a continuous function on D. And then since it is a continuous function on D, I can say that f is differentiable on D. Since continuous on D, because it was a polynomial, a linear, this is a linear function. It's a linear function. And since it was continuous, I can say f is differentiable on T. So this was the third question. And the fourth question is to find the stationary point. And you know how to find the stationary point. You need to equate the gradient equal to 0. And the gradient you have already found out here. So this is the gradient. So if I equate to 0 vector, I got 1 minus y equal to 0, y equals to 1. And I also got 1 minus x equal to 0, x equals to 1. So this is the stationary point which I found out. Is it clear now? Is it clear or still you have any question? Okay. So the last part for this question to find out the minimum and maximum of f on D. So let's check. Okay. So we have a function. Let me rewrite the function. F is x plus y minus xy, and my D is this one. And I have a stationary point as well. It is 1, 1. Okay, let's now check the minimum and maximum point, minimum and maximum of f on D. So basically in this type of question, there is a trick to consider some points which are like more critical. It can give you the minimum and maximum point more faster than considering just random points. So let's just go back here. Okay, here if you see, you have you have to consider those border points, because always remember, if you have a figure and this kind of things, and the border points are always critical to give you a minimum point or a maximum point. Let's just check with the border points. If you take f 0 comma 0, you will get 0, because x 0 plus 0 minus 0, so it's gonna be 0. And if you check the next point, x 0 comma 3 is gonna be uh, 3, and if you check x 3 comma 0 is also going to be 3, and let's just check on the stationary point as well. And if you put 1 comma 1, it's gonna be 1 plus 1 minus 1, 1 plus 1 minus 1 is 1. So this is neither minimum nor maximum, not mean or max, the stationary point. And these, so this is a minimum point, this is a max. So what you have to write, 0 comma 0 is a minimum point of f on D, where minimum value of f is 0. Similarly, 3 comma 0, 0 comma 3, are the maximum point of f on D, where the max value of f is 3. So this completes this question. Do you have any doubt in the last part?
Yes. How can we
Yeah.
know that 0 is the minimum value of f and
Uh,
3 is the maximum?
okay. So if you consider our domain here, your
Mhm.
x lies between 0 to 3, and your y lies between 0 to 3. And see, this is a very general and very direct exercise. So from here, if you see the lowest value of x is 0 and the lowest value of y is 0, and if you substitute 0 0 minus x y, so it's gonna be 0. And you know, the your domain is not non-negative, so your domain is just this part. So if you take the lowest possible value of this function is 0 comma 0, and if I substitute here in the value, you got the lowest possible form. And if you take any other value other than this, it you will see, okay, you are adding two values and then you are subtracting the product of this one. Anyway, it's gonna be like more than 0.
Okay. Thank you.
Okay, so uh, the overall idea of solving this question was to give a generic point of view, like how we gonna solve the exam questions. Like here, what we got to know, we okay, we got to know what is the meaning of compact, how to find it, and then we got to know how to check whether the function is differentiable on D or not. Then we also practice how to find the stationary point, and then for minimum maximum we got one method, like to check the border points and then to test them whether it is a minimum point or a maximum point. Is it clear, this question? Any doubt? Okay. Okay, for the next exercise, it's gonna be a little bit difficult than this one. So this is a function, and on d is given as x comma y that belongs to r square. Okay, so this is a question, and we have a break of 10-15 minutes, let's say 10 minutes, and in that break i I suggest you to try this question, and you can try with the first beat, or maybe you can also try to find the stationary points. uh, you can also send me your solution by WhatsApp. I'm gonna check whether whatever you understood in the first question, whether it is correct or wrong, and then we will solve it together. But for the first time, i'm giving you I'm giving you some time to try by your own, so that you can know your own mistakes, whatever you're doing when we're gonna solve these questions together. But first of all, give a try, and then send me a solution in WhatsApp. So I'm waiting for 10-15 minutes. I will check your solution, then we will move. So how is going on? Are you able to solve the first beat and the third beat as well? If you have solved, you can share me in the WhatsApp, even if it is partially correct and you don't believe that it is correct or wrong. So you can just share me. It's fine. Okay. So do you want me to solve or you want some time to try? Okay. Anyone who wants time to try? You can have like more 2-3 minutes and then I'm gonna solve it. And if I don't receive any response, I'm gonna start it right now. Okay. So just a minute. Okay. First question, we have to draw D, and it's kind of similar than to the last one. So here it has been given that x plus modulus of y must be less than equals to 4. So this is 4 minus x. Just a minute. There was a mistake in the question. It was x square plus mod of y less than equals to 4. So I got this one. And then if you remove the modulus, it's gonna be minus 4 minus x square y. Is it clear here until now? So we have just okay. So now we have two parts. First part is this one, and the second part is here. So if you observe on the first part is um, y must be sorry, y must be less than x square minus 4. I just reverse the sign. And the second part, y must be, sorry, this one is y must be greater than, and for this part, y must be less than 4 minus x square. So if you remove the inequality and if you just see the equation, like, can anyone say me this equation belongs to which geometrical figure? Line, circle, parabola, hyperbola, ellipse. Anyone? Okay. So this is this is a parabola. And if you try to draw this one, Just a minute. So let me draw this part first. So if you put x equals to 0, y equals to 4, when x equal to 0. So when y equal to 0, you have x equals to plus 2 or minus 2. So you have these 2 points. And when x equal to 0, the y equals to 4. So this is an equation of parabola. Just a minute. Let me take the coordinates properly. Yes. So here is minus 2 comma 0 and here is 2 comma 0. So this is the equation of x square minus 4. And similarly, this is the reverse equation because this is the negative of that one. So if you want to draw this one, it's gonna be like this. Points are same. Here is minus 4. Sorry. This one is minus 4 and this one is 4 comma 0. And then rest of the points are same. So your D is saying that your y is greater than this one. So your y is greater than this one. That's this part. And your y is smaller than this part. So if you draw this, if you combine both of them, it's gonna be the simple thing. So where this point is 4 comma 0 and this is minus 4 comma 0, this is minus 2 comma, sorry, this is 0 comma 4, this is 0 comma minus 4, this is minus 2 comma 0 and 2 comma 0 and 0 comma 0 is inside. Do you agree? So is it clear how to draw D? I just broke into small components, I draw together and then I join them. Any questions here? Okay. So this was my first part. Let's go to the second part. Just a minute. Second part is to find the sine of f. So what is sine of f? You have to check for what value of x and y, like f is positive or f is negative. So you have to find out the sign for different values of x and y. So let's find out where my function is always positive. So the function of x and y, let's just check where my function is always positive. And if you check what is my function is x square multiply with 1 minus y square. So my function is x square 1 minus y, not y square, sorry. Yeah, I want to check for what value of x and y this whole function is positive. And you know this is x square will be always positive. So I just need to consider for 1 minus y. So for what value of 1 minus y is positive. So this one is for any value of x. This whole function will be positive. Doesn't matter because it's an x square. And for y, if your y is greater than, sorry, if your y is less than 1, this function gonna be positive. So if I draw the domain once again, I'm not good at drawing. Sorry. Okay, whatever it is. Here we have 0 comma 4, and this is 0 comma minus 4, and here we have minus 2 comma 0, 2 comma 0, and your y equals to 1 line lies here. This y equals to 1, and if this y is less than 1, that means my function is positive. Minute. Yeah. So for y less than 1, it means this part. Just a minute. Okay. So for y less than 1 means this area. In this area, your f is going to be negative, and the rest of the area, your f is going to be positive. Okay. So is it clear, this part? Like how I find out the sign of f? I checked where my function is positive, so I got this one, and then I showed it um, with respect to d, and then I got this one. So for y less than 1, my function is going to be positive here, and then for the rest of the part is negative. Is it clear? Any questions? Okay. So let's move to the next part. Next part was find the stationary points. Okay. So before going to the stationary point, I want to check whether D is compact or not. Is D compact? How to check? First thing, D must be closed. The second thing, D must be bounded. So if for this one, if you see our D is made up of uh, continuous function and inequalities, and if you see this is an inequality, and if you break down, this is the function which I got. This is a quadratic function, this is a quadratic function, and you have inequality. So yes. Why? Because you have continuous functions and inequality. You can write in better way. It is defined by a inequality with a continuous function. For this reason, I can say this is closed and is D-bounded. For bounded, you have to find the upper boundary and lower boundary of the variables, and if you don't get any, if the function is going to infinity or something, then you have to say, okay, this is not bounded. So since it is not bounded, it is not compact. So if you observe this graph as well, uh, the maximum value and the minimum value of x is lies between -2 to 2 for x, and for y is lies between -4 to 4, -4 to 4 for y. So it is bounded. So D is bounded, and since D is closed and bounded, I can say D is compact. Is it clear? Any doubt? Okay. So you might have a question why I checked whether D is compact or not, because there was no such questions for checking D compact or not. You just asked with to draw D, find the sign of F. We did it, but there is no such question for checking whether D is compact or not. You will see why I checked for D is compact or not, why it is important. There is a theorem. So if D is compact and F is a continuous function, then according to Wester's theorem, there is an minimum, so the global minimum maximum. The global minimum from the term global is the maximum term and the minimum term for the whole function rather than for a small subset. It is a maximum function and the whole is a maximum point and the minimum point for the whole function. So that's why it is called as global minimum maximum. Points of F on D. So basically why I checked whether D is compact or not. If D is compact and my function is continuous on D, according to Wester's theorem, there will be a global minimum and maximum points of F which will be on D. That's a for sure. There's a for sure that there gonna be a global and a global minimum and global maximum points of F, and that will belongs to D. Because of this last bit, so since the last bit was asking to check the minimum and maximum points of F on D, so for that reason, I checked my D is compact or not. And since D is compact, that means I know that there is a point exist. So yeah, and let's get back to our original question. Check for the stationary points. So for the third question, stationary points of F on D. So how to find out? It's a very simple thing. You have to check, you have to find the gradient and then you have to equate it to 0. Let's find out the gradient. And the gradient is partial derivative of F with respect to X, the partial derivative of F with respect to Y. And let's just find out this one and this one. So the partial derivative of F with respect to X, let's just see what was our F. It was X square 1 minus Y. So my F is X square 1 minus Y. And if you for this one, it's gonna be this term if you're finding the partial derivative with respect to X. So the second term is gonna be constant. So you can take out outside and then you have to find the derivative of X square with respect to this one, which gonna be 1 minus Y to X. The derivative of X square with respect to X. And why this term I took out outside? Because this is a constant. So there is no X here. So for if you're finding the derivative, if you're finding the change of what is the derivative? Derivative, you are finding the change. Now you are observing the change. So in this value, what is the change in X? Is there any change in X? No, because x is constant. For any value of y, x will be constant. So I have to treat this thing as a constant. And when you are finding derivative, let's say a x with respect to dy dx, so if a is a constant, you take out a and then you find out dx by dx, which is 1. So the similar thing I did it here. Instead of x square, that was instead of x it was x square. So a I took it outside, and then dx x square, so it's gonna be 2ax. So here this is my a. Similarly, if you want to find um, for this thing here, you have to treat the x square as constant, so I took out x square. Then you have to find the derivative of this thing. So again you have to go here. What is the derivative of 1? Derivative of 1 is a constant, so it's 0. So it's gonna be x square, and derivative of minus y is minus 1. So I got minus x square. This one and this one. So what I got, my partial derivative of f with respect to x is 1 minus y multiplied with 2x. This one I got negative x square. And clearly both of them, they are continuous on D, and since they are continuous on D, what I can say, f is differentiable on D. But our question was to find the stationary point. So how do we find the stationary point? We will equate this to 0. For finding the stationary point, we will equate this to 0 and we will equate this to 0. So to find the stationary point, 1 minus y 2x equal to 0 minus x square equal to 0. So if you take x equals to 0, because negative x square equal to 0, that means x equal to 0. Here is gonna be 1 minus y 0 equal to 0. So what I got here, x equals to 0 and y is free, so y equals to y. So what is my stationary point? My stationary point is 0 comma y, where y belongs to R, but this 0 comma y must be inside D, inside D. So what is the constant of y inside D? So if you check, the constant for y inside D is, it must be less than, like, it has a boundary -4 to +4. So the y must be -4 to 4, because it must be inside D, as we are finding the stationary point of f on D. So you shouldn't write this thing. Rather, your boundaries is this one. Is it clear, this part? Any doubt? Any questions? Guys, are you there? Okay, repeat this part. You want the stationary part or or the previous part, the compact part? Okay, so for stationary point, what we need to do, compared to last question, we have to find the gradient of f and then you have to equate to 0. How to find the gradient of f? It is the partial derivative of f with respect to x, partial derivative of f with respect to y, and if we have also z, we find the partial derivative of f with respect to z. So how to find the partial derivative of f with respect to x? So if we are finding the partial derivative with respect to x, remember derivative is you are observing the change. So I am observing the change of this function with respect to x. So if I'm observing this function with respect to x for this part, you see there is no x term here. That means for any value of y, this is constant. So with respect to x, this is constant. So I have to treat it as a constant. So I will take it out and then I will find the derivative of this one. So when I found the partial derivative of this one, I got this part 1 minus y to x. And then you have to find similarly, you have to find the partial derivative of this function with respect to y, and I got minus x square because I have to treat this one as a constant because there is no y for any value of x. This function is going to be constant. And then I got my partial derivative with respect to x and I got the partial derivative with respect to y. And then I just did one more thing. I checked this one and this one as continuous. So this is a continuous function, your partial derivative of x and your partial derivative of y. Sorry, your partial derivative of f with respect to x and y, they are constant. Sorry, they are continuous. That means this function is differentiable on D. And then I came back to the original question, how to find the stationary point. For finding the stationary point, you just need to equate this to 0 and this to 0. And when I equate them to 0, I got x equals to 0 here. And if you put x equals to 0, this term will always be 0. So that means your y is free variable from linear algebra and your x is 0 and y is y. And this point must be inside D because my question was to find the stationary point of f on D or maybe inside D. So you have to check the constant what gonna be the maximum and minimum value of y to be inside D. So this point I got from the figure is from -4 to +4. -4 to +4. Is it clear now? Okay. So let's go back to the next question. The last and most important one. D or E, I don't know, to find the minimum and maximum of f on D. Any idea how we're gonna solve this one? Also, you have solved this. See, the minimum and maximum to find out the minimum and maximum point of f on D. There are actually several tricks. So this thing you must it must require your analytical mathematics skills to understand in what way we should find out the minimum and maximum. uh, Before this questions, all the questions were kind of general, so you don't need to worry about, but this is the most important one, and it also contains the contains the maximum point, I guess 3 point. If this whole question is, let's say, um, of 7 points, there's gonna be 3 points. So uh, it's not it's not pretty direct, you don't have any direct procedure for every question to solve it, but for the easier questions you can observe on stationary points. Here we got a series of stationary point. You see, we don't got a single stationary point, we got 0 comma y. It's a complete range of stationary points. And in some questions you will get this, let's say, 4 5 stationary points, and from the figure you can clearly observe the uh, the border points. Also here we can observe the border point. This is a border, this is a border, and this is a border, and this is a border. So and those cases, what you're gonna do, you can just randomly check on uh, the border points and the stationary points, and then you can give a conclusion on the minimum and maximum. Here also you can do that, but you don't have directly as stationary point. You know, you have a series of stationary point. It's this, so your y is free, so your y gonna be any value from -4 to 4. So let's just proceed with the general method how to find the minimum and maximum. And uh, for sure you can do it in any way, but this is the most general way and most calculus way to find out the minimum and maximum. Let me just solve this one. Okay, so if you see our d, uh, it's gonna be something like here. So this was my d, this is my d, and this point is 0 comma 4, and this is 0 comma -4, -2 comma 0, and 0 comma, sorry, 2 comma 0. Here you have y equals to 1, and above this my function was the sign of the function was negative here. So sign of the function was negative, and below this is negative. Below the sign of the function is positive. So let's check what is the value of function on 0 comma 4, and let's check what is the value of function on 0 comma -4. So if you substitute 0 comma 4 in the function, what was the function? The function was just a minute, x square 1 minus y. So my function was x square 1 minus y. And if you substitute the value of 0 comma 4 here, you will get 0 0. So if you observe this one, your function gonna be like same from here. Let me just use the highlighter. So in this part your function is 0, and in this part your function is 0. So it's somewhere it's like in here your sign of the function is negative, and then the sign of the function is positive. So let's just break into more simple part. It will be more clear. So if you see, if I break my domain into two parts, S1, S2. So this is my S1, and if you write the equation of S1, so the equation of S1 is gonna be uh, y equals to 4 minus x square, because it was given in the question as well, and also you can observe it. This was the equation of x1, and any point on S1, let's say x comma y, will be x comma 4 minus x square, right? Like, because I substitute instead of y, I substitute this one. So this is the any random point in S1. And if you substitute this point in the function, what was our function? Our function was x square 1 minus y. So let's substitute this function, this point inside the function. So x remains the same, and instead of y, I substitute 4 minus x square, and there's a my negative sign outside, so everything got reversed. So this is x square, and here I got x square minus 3. Okay, and let's just mark it as g of x because this function, I just removed y from this whole function. So I got this function with respect to x only, and I marked it as g of x. And let's just observe g of x a bit more. Uh, if you see, it's an x square, and you have x square minus 3. So g of x, and let's substitute x equals to 0. If you substitute x equals to 0, you get 0. And what is the maximum value of x? The maximum value of x was, if you see, the minimum value is 2 and the maximum value is 3. So the maximum value is, minimum value is minus 2. The maximum value was 2 for x. And for y was minus 4 to plus 4. So if I substitute x equals to 2 here, let's check. It's gonna be 4. And here's 4. And here 4 minus 1. So I got 4. And let's also substitute x equals to minus 2. It's gonna be the same because you have a square, so your negative doesn't impact that much. I cannot say here directly that okay, 0 is a minimum point. Rather, let's go a bit deeper. Let's find out the derivative of g of x. So if you find out the derivative of g of x, you will get 2x x minus 3 plus x square 2x. This is the product rule, u v. So if you're finding the derivative of u product v is going to be uh, derivative of u multiply with v plus derivative of v multiply u. So it's a product rule. You can check if you have doubt here. Okay, so this is my derivative of g of x, and let's check where this derivative of g of x is positive. So this is a technique to find the minimum and maximum term as well. So this is a method. I find out the derivative of the function, and then I'm checking at what point this function is positive. And for now, I'm considering x is greater than equal to 0. I have to also consider when x is negative as well, but it's going to be the similar thing because here it is x squared. So you will get the similar pattern for x less than equal x less than 0. So if you observe this thing here, you will get, just a minute. You have here, this one is 2x x square minus 3 plus you have 2x cube, right? Okay, or maybe you can do one thing. You can take common 2x from here. So it's x square minus 3 plus x square. So there was a 2x here, there was a 2x here. I took common, and then I got 2x square minus 3. And since I'm finding out for what value of x this whole function is positive, and I'm considering x is greater than equal to 0. Since x is greater than equal to 0, this one will be always positive, and I have to check for this thing. And this thing, I have to check 2x square minus 3 must be greater than equal to 0. That means x must be greater than equal to 3 by 2. And please note, I have assumed that x is greater than equal to 0. So for the similar case, you will get if x is less than 0, you will get the negative version of this one, minus 3 by 2. Sorry, minus root over of 3 by 2. So let's just summarize the thing what we got here. We have derivative of g, and we have 2 points. One is I'm starting from 0. I'm not considering the negative part. 3 by root over of 3 by 2, and then we have 2. So this is the maximum value of x, and this is the 0 which I have assumed. And until I got this one, x is greater than or equals to root 3 by root 2. That means for this part, my g dash of x is positive. That means this is positive here, and the rest of this part is negative. Like any other case will be negative. And since if my g dash is like the derivative of g is negative, that means my function is decreasing. And if my g dash is positive, like the derivative is positive, then the function is increasing. So uh, this is general idea from calculus 1. So if you have any doubt, you can just revise calculus 1 a bit and get it. And also you can watch this one. The video is going to be available, so you can also watch it several times. And we are going to solve a lot of questions using this method also. So this is the most general idea to find the minimum, point and the maximum. So from here, what we got? So for g, we got the minimum value is at x equals to root over of 3 by 2 for x is greater than equal to 0. And the maximum value I got is that x equals to, if you see the maximum value, x equals to 2. X equals to 2 for x greater than equal to 0. And similarly, for x less than 0, the minimum value will be at minus root over of 3 by 2, and the maximum value will be at x equals to minus 2, which I got here. X equals to minus 2, I got the maximum value. Max, and I got the minimum value here. So to find the exactly minimum value, what you can do, you can substitute this. What is the minimum value of f? So to find the minimum value of f on S1, because until now I didn't observe what will happen for S2. I'm just on S1, so I have to also consider for the second part. So the minimum value of f on S1 is gonna be, if you substitute this value in the function, you're gonna get, just a minute. So my f was x comma, just a minute, let's go back here. This was my f, so it's x square 1 minus y. Okay, and then you have to convert it back to this point, because I have already considered this one, and then I substitute here. So my point is here x comma, just a minute, x comma 4 minus x square. Yeah, this one. So this is 3 by 2 plus minus 3 by 2, and this is gonna be 4 minus 3 by 2, because the square, so I have to remove this one. So here it's gonna be plus minus 3 by 2, and this is 4, 8, 5 of 1, 2. So this is the minimum point on S1. And for the maximum one, so the point which I got is a similar pattern, x comma 4 minus x square. So this is gonna be plus minus 2, and here it's gonna be 4 minus plus. It doesn't matter whatever you take the sign, same, plus minus 2. Here is gonna be 0. So my maximum, and so my maximum point is 2 comma 0 and minus 2 comma 0. This is my maximum point. On S1, please note this is on S1, so I have to solve for S2 as well. So for S2, which is so this was my S1, so my S2 will be this part, and I want to leave this part for you, so you can watch the video once again, and the similar pattern which I have followed for S1 you can also find for S2, and then in the next class you have to tell me what is the minimum and maximum value of f on both S1 and S2. And what is my S1 and S2? I just, if you go back to the if you go back to previous steps, this was my whole D, and I broke D into two parts, S1 and S2. So if you combine them, the your question becomes minimum and maximum of f on T. So this is your tax to do this one. This is not difficult, but this is a bit lengthy. So you have to be careful at uh, like at each point, because if you make a simple mistake, you will get the wrong solutions. And this, as I have said you, there are multiple methods to solve this kind of questions to find the minimum point and maximum point. And then in the previous question, it was kind of um, very easy one, because we just observed the just because we just observe the border points and the stationary point. Also, you could have done the same here. You could have observed the border points minus 2 comma 0, 0 comma 4, 2 comma 0, and 0 comma minus 4, but then you have a stationary point also. uh, so that means you're not covering all the points, because our stationary point is not pretty direct here, because it is an combination of points as y is free. So also you have to do the same thing for S2, and then you have to combine it, and the final solution whatever you will get is for this one. It is a minimum and maximum of f on T. So I will let you know when the next class will be, but for now you have to do this one. And if also I will give you some task in the group. I will share it with you. Some exercises similar to past year exams, or maybe some concept building exercises which you're gonna solve it at the home, and then we're gonna discuss it. Is it clear? Like for sure, this is not that much direct. It's gonna be uh, like it's gonna be crystal clear in the first case. No, you have to solve a lot of questions, actually maybe 10-15 questions to be expert in this minimum and maximum. And you don't need to worry about, for example, as I have said you before, this question is gonna be of 3 points, this minimum and maximum. And uh, even if you solve half, you get like 1.5, and if you try the other part, you will get 2 out of 3. So even if it's a difficult question, if it is an easy question, you will try to get the maximum point. But in some cases, it's become so lengthy that don't spend so much time, you find the direct one, you find the border points, you check the stationary points, you find the value, and if you have time, do it. But you have to be perfect in time management. You have 5 questions and the time limit, I think 2 hours 2 hours 30 minutes. So you have to give 30 minutes for each question. So if you're spending more than that, that means you have to, uh, like you have to spend less time in some question. So you have to be very careful. But again, you have to practice a lot. I will share you a lot of exercises, a lot of questions where you can practice some easier exercises, some intermediate, and some difficult. And for the next class, I will pick some past year exercises similar to this, and we're gonna solve that one. And I will let you know when the next class is. Do you have any questions? If you have no questions, we can stop here, and I will share you the recording in few minutes. Okay. Same to you. Have a nice day.